just had a geometry student that had this page of material. I thought I'd leave it up in case it was the same thing you have. Ratios, proportions, and percent?
We got further than that, though.
Okay. Go ahead. If you got something new, send it to me, or if you can read it to me, I can write it and we can just do it.
I did. I sent it to you.
Okay. Hold on a minute. Pull up my email here. It's not that easy to do on this. Yeah, there it is. Which page should I pull up first? I'm not sure I know how to rotate the one.
Let's start with that one then. Just because there's only 2 on that page.
Yeah, I'm not sure. I ran into this difficulty the other day where I couldn't figure out how to rotate it. It doesn't seem to give me that choice. I can expand it. At least I know how to do that now.
That's fine then. We don't have to do those. There's only 2. I can figure those out.
Well, or you could read them.
Okay, that works.
But we'll start with this one at the top.
Okay.
Alright, so let's work each of these problems. Gia paid how much? She paid $8 for her ticket.
Yeah.
Children are half price if you're under 12. So what did her daughter pay?
Half price.
What amount?
Oh, 4.
And her grandmother gets a 25% discount. So what did grandma pay?
25 of 8. 6.
Uh-huh. Now, let's read the last sentence. What percent of the full retail price did Gia pay for the 3 tickets? Well, she paid a total of $18. And what would the retail price have been for 3 tickets? There were no discounts.
$24.
What is that percentage right there?
75%.
Right, that's 3/4. Okay. So that's the way to tackle these, is just to go through it step by step and then make sure you read their question really good. It's a little different than the word problems you were doing last time we talked, where I said the first step is always define your variables. Notice that I didn't do that on this problem. I just kind of worked through it, knowing that what they want is how much did she pay for 3 tickets divided by how much would 3 tickets have cost if there were no discounts. That's what they're asking. And so that's all I had to do. And there really was, I don't know, I could probably go back and figure out the variable to use, but I didn't need to use it. I just had to understand the nature of the problem, which does make them a little harder because it's a little easier if you can immediately define your variables. Hold on, let me get this down below where, okay, let's look at 17. So the dealer paid $60 for it. That's the dealer cost. He wants to offer a 10% off the price marked on the tag, but he still wants to make a 20% profit over cost. What's the next thing we should figure out?
How much 20% or 10% would be?
No, let's work with the middle party. Let's work with his profit. If he needs to make a 20% profit, what does he need to sell it for? The retail price. No, excuse me, the price that he sells it for, whether I call it retail or not.
$12?
Well, 60 plus 12.
Oh, 72.
Right. In other words, if he sells it for $72, if that's how much he gets in cash, he will have made a $12 profit, which will represent a 20% profit. But now we go and look at the first part of that middle sentence. He wants to offer it to the customers at a discount of 10%. So he clearly cannot offer it to the customers at $72. Because if he gave them a 10% discount, they'd take off $7.20 and he would not make his profit that he needs to make. So, if I want to set this up algebraically, here's what I need to do. Let's go back and define the variable, x. What's x going to equal? X is going to equal the listed price. Sound like a good thing to make x? You can generally find your variables by reading the last part of the last sentence. And to be honest, that's what I should have done here. I should have gone immediately, what price should be placed on the tag? That's the list price. Okay? So, if x is the list price, what equation can I write?
Would it be 72 times 0.1 equals x?
Almost. He wants to give the customer a 10% discount. So if I do that, that has to equal $72. If the customer is getting a 10% discount, then 90% of the list price is what they're going to pay, right? If you went into a store and they were giving you a 10% discount, you'd multiply whatever price you saw on the sticker by 90%. That's the quick way to do it. The slow way is to multiply it by 10% and subtract that amount from 72. But the fast way to figure it out is you take 90% of the list price, and that needs to equal 72 because this is what the dealer wants to get paid. He wants to make sure he makes a $12 profit. So now all I have to do is solve this equation. What's x equal to?
80.
Yeah, now let's go back and let's just check that. Okay, so if the list price is 80, the customer is going to get 10% off. So they're only going to pay 72. So the dealer pockets $72. He paid $60 for it. He's made a 20% profit. Okay? These are more difficult than your average word problems, but still quite doable. So this table applies to the next two questions.
Mm-hmm.
This is very typical of a science question that you would get on the ACT. Have you taken the ACT yet, or a preliminary one?
No, we take it in a little, like a week or two or something.
Okay. So let's look at that table. About what percentage of sophomore and junior students are enrolled in Calc 1?
61 out of 30, or 32 and 61.
Well, in order to answer that question, don't we need to know the total number of sophomore and junior students?
So 93.
Hold on. Read the table. The totals are over on the right side. How many total sophomores and juniors are there?
Sophomores are 212 and juniors are 157.
Add those together. That's their total.
360.
Now, how many sophomores and juniors total are taking Calc 1?
93.
Now, convert that to a percentage or a decimal.
Okay. 25%.
Okay. Number 19. In the spring of 2014, there were 752 students enrolled. This was the fall of 2014, this table. So they're saying that in the following spring, no, hold on, no they're not. The spring comes before the fall. So in the spring, there were 752 students enrolled in mathematics, as opposed to the fall where it looks like there's 639 students enrolled in mathematics. But that doesn't matter. If 38% of the students were taking college algebra, how many students took college algebra more in the spring than in the fall? So X is going to be the number of students that took it in the spring. Number of math, or not math, college algebra.
Wouldn't it just be 62 because that's what's left out of 100?
Well, start this second sentence. If 32% of the students were taking college algebra, they tell you how many students there were, 752. So let's figure out how many students out of 752 were taking college algebra. So what's that going to be equal to?
X over 752.
It's simpler than that. 752 times what?
0.38.
Yeah. What is that number? That's the number of students that were taking college algebra in the spring. What is it? Should be a whole number.
285.76.
You sure you did that in the calculator? Hold on. Let me do it. 752 times 752 times 0.38. Yeah. Interesting. I guess they rounded off their 38%. Wasn't exactly 38%. Because you can't have a half a person.
Yeah.
So we have, I rounded up, so we have 286 people who were taking college algebra in the spring of 2014. How many people were taking college algebra in the fall of 2014?
Would that be everybody left over?
Now, look at the table. See the college algebra? How many total are taking college algebra? These tables always have a total across the bottom and along the right side.
But how is that possible? Because if you read the sentence above the thing, it says 639 students in mathematics class. But this one was 752.
Because there were more students in the spring. Some of them didn't make it to the fall. Remember, the spring comes before the fall. So this place had 752 math students in the spring. By the fall, they were down to 639 total math students. But how many math students took college algebra in the fall? That number right there, 256. See that?
Yeah.
Okay. Now let's answer the question. How many more students took college algebra in the spring than in the fall?
30.
Yeah. Easy. Okay. There was never anything tough about this problem. It's just, it's kind of why I call the science questions really more reading than they are math. There's rarely hard math on the science questions on the ACT test. It's all about understanding the tables you're looking at, the graphs you're looking at, or information that they're giving you. But keep that in mind about a table like this. Is your totals are always going to be across the bottom and the right side. That's the total number of freshmen in the fall, total number of sophomores, so forth and so on. Okay, let me blow this one up a little bit. In fact, yeah, I don't think I'm going to need to write much here. Just make sure we can see it. All right. What we're looking at is the growth of two different savings accounts. Each has a different amount of compound interest. Maybe one's at 4%, the other's at 5%. The investor does not withdraw or deposit any money over the entire life. The amount of money in each account is shown below. Which of the following is a correct statement about the data? Well, we need to go through all four statements. At time 0, the amount in account 1 is equal to the amount in account 2. True or false?
It doesn't really, no, it starts at 100.
What's this point right there? There's time 0. Remember, he puts $100 into both accounts each. Two different savings accounts.
Okay.
So therefore, at time 0, the amount of money in account 1 is indeed equal to the amount of money in account 2. You can see it from the graph. You can also figure it out from the words in the paragraph. Notice that at the 5-day mark, account 2 has grown faster than account 1. So they no longer have the same amount of money, or the 5-year mark maybe. I don't know what that 5 is in terms of time. It's probably years. Maybe, yeah, it's the only thing that would make sense. But let's read the rest of it. At time t equal 5, account 1 has about 10% more money than account 2. Well, if we go over the 5 there, account 1 has less money. You see that? Okay, and then C says, at time 10, so let's put the cursor on 10, account 2 has 50% more money than account 1. Well, account 2 looks like it has about 125. Account 1 looks like it has about 120. See that? In other words, there's account 2. It's close to 125, maybe 128. There's account 1. It's got exactly 120 in it. So it's nowhere near 50% more. And finally, for D, for the first 15 units of time, the amount of money in account 1 is increasing more quickly than account 2. Well, that's pretty crazy. We can see from the two curves that account 2 is always the best one. There's no point in time where account 1 is doing better than account 2. There's only one place where they're equal, and that's at the start, when they both had $100 put in them. All right. Let's see if I can figure out how to rotate this. You have any ideas? You have Windows 10, don't you?
No, I have the earlier one.
Like 7 or 8?
Yeah.
Pop out, close, details. Details. I tell you what, I can read 14. Since we only have 3 minutes more and I don't think I'm going to figure it out, let me see.
14 is the one I'm confused about.
Okay, good. Let's do 14.
Okay.
So, if 150% of j is equal to half of k, then j over k is. So, read to me exactly how I need to write that equation. From starting word to the last word. How can I write the equation if 150% of j is equal to half of k? Tell me how to write that.
It could be j.
What's it say? It says 150% of j.
100.
What decimal?
Times j?
You can't use percentages in equations, so you always need to convert percentages to decimal.
1.5 times j
is equal to?
Equals 1/2 of k.
Yeah, well, since we have a decimal, let's keep it in decimal, okay? Now they want to know what j over k is. Well, how do I get j over k?
You divide k.
Not k. You divide j by k. You divide both sides of the equation by k. That's the answer I'm looking for. Okay? In other words, the first step, I'm going to divide both sides by k. Now that gets rid of that, and now I almost have j over k. I got 1.5 times j over k, so how do I get rid of the 1.5? So that I'm left with precisely j over k.
Divide by 1.5?
Yeah, so you got 0.5 divided by 1.5. What's that number? What is it?
What is it? I
You don't need a calculator. You got 1/2 divided by 3/2. What part of 1/2, or what part of 1.5 is 0.5?
Is it 1/3?
Yeah, so that fraction is 1/3. If you prefer, I'll divide the top by 0.5 and the bottom by 0.5. And that gives me exactly 1/3. But you should be able to look at 0.5 over 1.5 and know that's 1 over 3. I mean, that's not something you really need to have to do more algebra on. You want to start recognizing these kind of ratios. All right. good stopping spot. I will talk to you next time.
All right, thank you.
All right, Quade. Bye-bye.